Hello and welcome to my channel. I'm making this video after a long time, so let's not waste any time and jump on to the today's project. So today I'm going to show how we can build end-to-end data pipeline for any string or news sentiment analysis. So this is how the flow will look like. We would have a producer which is written in Python. That producer will be generating random text of string, and it will post to a topic in Kafka. Now after that, once it is produced to that Kafka topic, we would have a Python consumer which will be reading those texts from that topic as they come, and it would run a sentiment analysis on it. We will be using Python's existing library called NLTK, because this course is not about this video is not about machine learning. So we would be making use of that, and that library basically takes in a string and gives us a value which is basically, if it's greater than zero point 0.5, then there is a chance it is of positive sentiment. If it's less than that zero point 0.5, it is of negative sentiment, something like that. So but yeah, we don't care about the values. Those values can be used for some machine learning model analysis later on by any ML engineer. We are right now focusing on the data pipeline. So we would run the sentiment analysis, like get those values, and we will store those values in the Postgres. Now obviously when you store anything in database, as these are called feature value. Now once these feature values are created, anyone can pull them up. So in our case, we would be basically pulling them to Streamlit for UI purposes. And this is how our pipeline will look like. We will have a Python producer producing text to Kafka. Then we would have a Python consumer pulling that data from Kafka, running sentiment analysis and storing that sentiment analysis values in Postgres. And then we would have a Streamlit app that will pull in those texts and their sentiment analysis values and display it on the screen. And this is how our UI will look like finally when we run our all the containers. So yeah, one more thing, we would be running all of these under inside Docker, so that is good. um, and this is how the UI will look. We would have a title. It is not nicely formatted. You guys can do the UI work. Like, I'm not good with UI, but this is to show how things will display. So let's jump on to the coding part. So I have a directory. Okay, one more thing. I make sure that you have Docker desktop installed. Basically, you should have Docker installed on your computer, so that we can create Docker images and then run them as containers. So as I said, we would have one Kafka consumer, we would have one Kafka producer, and then, oh sorry, I think I created inside of this. Yeah, we would have Kafka producer, and then we would have Postgres, and then we would have UI. Okay, so these are the containers. Kafka we would be running in Docker, but for that we don't need any folder, because we will directly give our information in our Docker compose file. So we would have a Docker compose or YML file. Cool. So let's start with producer first. So in producer, I would have the following files. Obviously, I would need Docker file, because that is what it gives information what this container will consist of. Then I would have Python producer.py file, and then I would have requirements.txt. These are just the libraries that the container would need. And then I also have a file. In my previous video also I have used this. Basically this is my existing code file, and you can copy and paste it as it is. What it does is, it has a bunch of logic. Basically, if you go back to the diagram, um, my Python producer, because it is producing to Kafka, imagine that the Kafka is not up yet. I know in Docker Compose we can provide depends on Kafka, right? But still, even when the Kafka container is up, it does take time for it to, have those topics and everything, all the channels ready. So I basically I have a script in which I basically wait for few more seconds before I start producing to the Kafka topic. Yeah, so this is that shell script, and we would have all these configuration in the Docker file. I can basically start adding it to our Docker file. So this is how our Docker file will look like. Um, yeah, so basically we are providing the image name. Yeah, that it's 3.8 slim because we don't need extra dependencies. Copy the requirements.txt file from here and then run the setup, because we would need to install these requirements locally in the Docker container. Then copy paste this sh file, um, add the Python producer file, because this is a script that we will run, and this is a command. So what I'm doing is I'm running this wait script for 30 seconds, wait for the zookeeper to come up, because zookeeper is something that manages Kafka brokers. So it first waits for zookeeper, then it waits for Kafka server. If all of this is good, then I'm running the Python producer. Now let me quickly get all the requirements.txt stuff. Okay, so I think we are good with Python producer. We can start coding it up. So it's gonna be a pretty small file. We would import time. um, we would import schedule. I think I should increase my font. Settings, let's see, font to maybe 16. Okay, yeah, this is better. From JSON import dumps from Faker. So Faker is a library which helps us to create random strings. That library has I don't know what is the amount, but a lot of strings, and we need that only for our um, tutorial purposes. Now this is Kafka. Now when we run the Kafka brokers in Docker YML, you will see the compose YML. You will see I will be running Kafka brokers on the port 9092. So this is for that, and I will give a topic, so that let's say sentence. Yeah, and now I will give definition. Yeah, before that let me write main. If oops So I'm basically producing this generate data every 5 seconds, like sleep for 5 seconds, then generate data. I'm initializing Faker object, and then I am initializing my producer. Kafka producer bootstrap servers is equal to Kafka nodes, and then value serializer is equal to dumps x dot encode utf8. Cool. So this is basically what it does is create a Kafka producer object, and then I'm dumping my values. Like basically we are producing those sentences to this topic, right? To the sentence topic. So this is the format in which it needs to dump. Uh, and then what data to dump would look like this: sentence faker dot sentence print my data. I'm just printing it to see that um, it works or not, because it helps us in the logs. We can check the logs of our containers, right? So value is equal to my data, and then we would do produce dot flush. Cool. So I think Python producer is almost done. We can jump on to the consumer side. So our consumer would look similar, like we would need a Docker file. We would need a requirements.txt file. We would need wait for it.sh, and we would need Python consumer.py. So let me copy paste everything from here. Yeah, this is going to be same. Cool. And then we would have requirements.txt. So these are my requirements for consumer, because as I said, we need that NLTK library. So that's there. And then our Docker file will look exactly same, except the part that it is producer or dot this. Oh, this should be here, sorry. Yeah, everything is same except the file name, right? So the container will come up. And then for consumer, now for consumer we need two things. One, the consumer basically reads the data from the topic, and then the consumer writes it to the Postgres. So for writing it to Postgres, we would need to make a connection to Postgres, right? So there is a library called G2, which is to connect to our Postgres DB, which is used for our Postgres DB NLTK download. These are all the codes that related to NLTK. I have copied it from Stack Overflow. I'm not well versed in machine learning stuff. So yeah, if you have any questions regarding it, I can help answer it, but I would need to do some research on it. DB name. Okay, so I'm just okay. So how this would work is when I am creating, when you will see in Postgres, the database information that I provide uh, should match this connection information. And technically, you should not hard code this in code. This should come from the environment values. But just for our quick demo purposes, we are doing it in this format. 5432. Okay, because Postgres will run on port 5432. um, Now our cursor is basically, cursor will keep track of, first we connect to the Postgres, and this is when we do it, when we connect it, the cursor is on the, like, okay, the database is empty. Now when we read from the topic, since then we would start writing it to this one, to our Postgres. Now here we'll do connect to Kafka. We'll do the same thing, Kafka nodes. As I said, the Kafka broker will be running on 9092, and then my topic, these should match the information that we provided in producer. My topic, bootstrap servers is equal to Kafka nodes, and then the value deserializer should be same. Let me copy that part from here. Okay, so we have the consumer objects. Now we'll do consume messages from the topic. Data is equal to message dot value. We are printing the data because I want to make sure that we are able to read the data that was produced. If you remember, I was printing out the data that I'm producing, so I'm gonna print as well to see that it works. Now scores is equal to analyzer dot polarity scores data sentence. If you remember, in producer I'm producing a dictionary which is my sentence as uh, sentence is the key, and then the faker dot sentence some random string. So this is the reason I am trying to access that sentence through this key, because data is a dictionary, and this polarity scores basically give us the score value. Print scores compound. Now this compound, so when we get polarity scores, we get negative, positive, and compound is basically a cumulative value. So we would insert data into Postgres SQL. Sentences. So my table name is sentences, so I'm doing sentences and sentiment values values modulus s. Okay, and then what are the values, which is data sentence, and then scores compound, correct? And then yeah, that's it. And then once our cursor is done, we do connect dot commit. Okay, I think we have everything from the producer to consumer. And let me now focus on the Postgres thing. So Postgres thing is going to be pretty straightforward. We would have a docker file, and then we would have a create table.sql. So our docker file will look something like this, where I'm pulling the Postgres latest image, and then I'm asking it to just copy paste this SQL file to this docker entry point initdb. So by default, anything inside this folder, and this folder will be inside the container. Okay, so anything inside this folder gets run as a SQL. So only SQL files can stay here, and because it's a Postgres DB container, the container is smart enough to look into this initdb folder and then run all the SQL files, whatever are there, and that's why our SQL file will stay there. And the SQL file will be very straightforward, which is create table sentences, if that was the name I gave here, consumer sentences. Okay, sentences, and then id serial primary key. So yeah, this id will be automatically generated by Postgres, because we need a primary key, right? um, and we know our sentences will be of this length max. It will be much shorter than this, but yeah, sentiment value is float, because yeah, it's as a float. NLTK gives us a float values. So let me quickly check sentence, compound, scores, compound. Okay, sentiment as float, and I'm using sentiment here. Okay, sentence. Okay, so I think my Postgres is up. Let's do this before jumping on to the UI. Let's see some logs and see if it's working or not. So for that, I'll quickly copy paste everything in my Docker Compose, except I'll remove this UI part, and I'll quickly go over how my Docker Compose looks like. So it is like this. I have my services. So as I said, Zookeeper and Kafka will be running in a container, but we don't need to code it because there are some images uh, available online. So Docker will be pulling from these images from Docker Hub, and Kafka is, we know Kafka is a broker. In the diagram we can see, where is the diagram? Yeah, here the Kafka is our broker, and Zookeeper is basically something that is useful for managing Kafka brokers. Then we would have a container, Kafka producer, which will basically produce our sentences, and just letting it out that it depends on these. It actually technically doesn't depend on Postgres, but from for the safe side I gave it. And then we have Kafka consumer, and then here is a Postgres, and the way they know which Docker file to read is through here. Context is dot slash Kafka consumer. So it looks into the Kafka consumer, and wherever it should have a Docker file, this folder should have a Docker file, and that's how it runs. And we know Kafka, we are running it on, technically Kafka runs on the 9092 port. So yeah, these are the environment values. Actually, I can use these environment values directly instead of hard coding it here. That's the point, all the point of passing it as environment variable. But yeah, I'm just using it as a hard code, and later we will see if we can change it with environment variables. So I think we have everything ready. The way to run is, I think it's docker compose up dash d. So once we run this, let it pull all the images. So it's pulling these images, I showed you, Kafka and Zookeeper from online. And for the other ones, we already have provided Docker file. So it should have it. Um, let's see. Once this is complete, yeah, it's doing Postgres. Okay, everything is done. So if we go to containers, okay, we see some error in the Kafka producer. So quickly look. Oh, permission denied. Okay, yeah, this has happened to me before. So let's bring everything down. Okay, so I'm just stopping everything. What has happened is, by default, my this is my setting. My computer basically changes the permission for wait for it. So I will have to go to each directory and then do chmod on 775. Wait for it. Let's see if the permission change. Okay, and then I have to do the same for Kafka producer, and then chmod. Okay, so I think it works now. I would just delete all the volumes that I had created and all the images that I had created. The containers are 0. I will quickly run. Okay, so I should go back to my parent folder, and I need to run docker compose up dash b. This time it will run the same thing. Yeah, let's see. Once the download is complete. Okay, so this time I see everything is running. Let's go to producer, waiting 30 seconds. So it is waiting 30 seconds, is available after 4 seconds. Yeah, see, the wait dot script is very helpful for us. Okay, so it gave us an error saying unrecognized configs. Let's see. Unrecognized config is Kafka consumer also slowing down? Okay, so I think Kafka consumer is downloading still. Okay, so I think Kafka consumer doesn't have an issue. I will go to my producer. um, X terms and code. I don't think there is issue in here. Kafka nodes is something. Bootstrap servers. Okay, I think I found the issue. There was a spelling mistake. Let me check consumer. Okay, consumer is good. Okay, so I think I would need to bring things down. Sorry for that, guys. Um, hmm. Okay, I will just for the safe side. I delete everything because images will be created again. So I will need to delete all the images. Not for Kafka and Zookeeper, but I prefer to delete all the images. Okay, so I think after this, we should be confident in seeing our Kafka producer to produce some messages and consumer to consume it. Okay, it's running. Let's see. It is waiting. Let's see, 2 seconds. Let's hope that it connects to Kafka. Okay, so it is able to produce. You can see it is producing nothing already. Say healthy wife. It will generate sentences every 5 seconds. So let me wait for one more message to be produced. It is taking time more than 5 seconds. Why? Oh, it exited. Okay, so let's see what happened there. And we have Kafka consumer running. Okay, Kafka consumer was able to get this data and it was able to run the sentiment analysis, but our producer seems to have logged out. um, hmm. Let's do this. Let me quickly bring it down because I want to see the logs. So in order to see the logs, um, I will bring them up and then I will. Okay, so Docker logs Kafka producer. Kafka producer exited. Hmm. Why is that happening? Let's see. Oh, I think I know because it will produce once and there is not a while loop to do that. Okay. I should basically use schedule because I have imported schedule, right? So every 10 dot seconds dot do gen data. I'll remove this. Actually, I don't need time dot sleep. Okay, so I think this will schedule it and then we would be generating. Oh, but I need a while loop too because it won't be able to run the background thing. So while true schedule dot run pending, like till the time it's running, time dot sleep. I think this was an issue. Let's reduce this time to 5. Okay, I have to bring down the stuff. Yeah, yeah, that's my mistake, guys. Sorry for the delay. We'll get to the UI quickly, and it's good that we are learning some debugging also along with working with um, data pipeline and Docker containers. Yeah, so now I'll go ahead and bring everything up. Yeah, this time it should, because yeah, there was not a while true. What was happening is, I was just generating the data once and then obviously the code will close. So this Python code would close and the producer basically is dependent on that service. If no service is running, the container exited out. And that's logical error. Yeah. And see, this time it's still running. And see, we can see, okay, two messages coming up. Okay. So I think let's see. Okay. Let's wait for another message. Okay. There are three messages. Let's go to Kafka consumer. Okay. We see the sentiment analysis. Now we what I also prefer to do is I prefer to basically go into my let me open a new tab, because we are producing we are consuming the messages and storing them in Postgres, so it would make sense that we basically log into our Postgres container psql-u and see for ourselves if the data is being generated. So using dt we see the table and then select star from sentences. Okay, we are seeing all the rows getting there. Okay, awesome. So I think this is working fine. So our data is being populated, everything's good. So I think what I'll do is I'll bring the services down because I don't want the memory to fill up. um, and now I'll uncomment this UI block, and you see we have this UI part left, right? So we'll start with that UI part, and in this UI part also there will be, oops, no folder, sorry. Yeah, there will be Docker file, there will be app.py that will have our UI changes. Then we have obviously requirements.txt, and then I think that's it. Yeah, so for Docker file I will have these changes. This is basically Python 3.9. Copy paste the requirements, run the requirements, and then just run this command. This is the command to basically run the Streamlit app. I'm running it with uh, cross this thing false, because otherwise it will error out. I know there are other changes to take care of, but yeah, this is the easiest way I found would work for me. So then I have this requirements, pretty much simple, because if you go back to the diagram, I need to make connection to the Postgres, and what I'm doing in my logic in my Streamlit app, I'm polling the database every, I think, 5 seconds, and I check for new data. If I find new data, I print it to the UI. Okay, so this is what I'm doing. So then I have Docker done, app.py is there. So let's code app.py. Yeah, so for app.py we would just do import streamlit as st. We would import time, we would import this library, import operational error, and then import logging. Okay, configure logging. So I like to log, because if there is any error on the server side, Streamlit itself doesn't log anything. I saw this, and then when I use this library, I started seeing all the errors. So as I said, I'm hard coding everything, but this should be passed as environment variables. So my DB name, DB user, now I will write a method to fetch data basically. Try, so I will do the connection again similar to what I did in the on the consumer side. So it will be host equal to db host, database, database equal to db name, user equal to db user, password. Again, we should never share this stuff. Is just for demo purposes that I am hard coding it, and yeah, just finding it easier way. Accept operational error as e. Actually, yeah, operational error could, we can just log it to Streamlit itself. And don't return anything, otherwise cursor connection dot cursor, and then I would execute it. Now when I am connected to my table, so like basically the database from sentences, now I get the rows, fetch all, I need all the rows. I will close the cursor dot close because it's not good to keep the connection hanging. So every time I'm polling, I make the connection, get the rows, and then return and then close the connection. I know it's not good because you should not open and close the connection. It takes some time, but right now we are not focusing on the latency part of the things. We just care about that the data is there. So yeah, so my fetch data is pretty straightforward. Then I just need to code my if name. I need to run a main code, and then I run the main. Oops. Now I just need to define my main method. Sentence data dashboard. So I'm running an infinite loop, and I will do a time dot sleep in that case. So if data is there for row in data. Now this, the reason for this unique ID is because every time I'm pulling all the rows, right? So let's say first time there are two rows, I pull both the rows. Now I display it on the UI. Now next time, by the time I'm running this fetch data again, there are five rows. So I pull all the five rows, but I should not print all the five rows again, right? We don't want to see all the five rows. We only want to see the new three rows. So that's the reason I'm using this unique ID. So yeah, and I get the row number. If ID in unique set, then continue, else st dot write. Actually don't write anything, just be an empty string, and then time dot sleep 5. Yeah, I think that's all we need. So let's see if I'll remove all of these. I don't, yeah, just to run everything from scratch. Actually this was not required because it would have been fast because these images were saved. um, let's run docker compose. This time we will see a UI image and a container for UI also created. And let me go to my browser in the meantime, and we can, okay, so if we go back to our code, if we go to docker compose UI, you can see it is running on port 8501. It is running, so we can go there, localhost 8051, and, or wait, was that the port? 8501, sorry, 8501. So we'll go here. Oh, okay, awesome. So we are able to see the index number. This is the string, and this is the sentiment analysis. For this one it's neutral, I guess. This one is somewhat negative, this one is negative. Audience has been clearly reduced. Edge word significance. Yeah, I don't know if these are correct English sentences. These are some random jumbled words, but yeah, I mean your producer source could be a good source. Like my source is a faker source, right? So um, that's why it's not working. Cool. I think that's all for today's video. If you guys liked my video, please subscribe and hit the like button and stay tuned for more videos like this. Thanks everyone.